To construct the fuselage for the Ansley PD, you will need at least one 30-inch long fuselage tube. I like to use a square cross-section, although a rectangular or even a triangular cross-section may be acceptable and beneficial to some builders, but the square is easy to build, the geometry internally and externally is accessible, fits in the hand well, launches well, and makes a good use of the internal space. A nose pod is another option and can be constructed in the same diameter and coupled on to the front of the aircraft. However, one 30-inch section properly balanced will fly just fine with the canard forward and the main wing mounted in the rear. Here you see three different fuselage tube diameters. This is a 2-inch nominal diameter, a 2.5-inch, and a 3-inch. The 3-inch internal diameter fuselage tube is really quite voluminous, in my opinion much bigger than you would need for the Ansley PD. It's just really quite large, and it's kind of a handful to grab to hand launch. The 2.5-inch has the paper removal interval at 2.5 inches with of course a 1/2 inch of paper removed at each corner, so that the actual internal diameter is 2 3/4 inches and the exterior diameter is 3 1/4 inches. This is a great choice for a large amount of internal volume. It still fits nicely into your hand for hand launches, and the added diameter provides a nice stiffness against torsion. And then the smaller diameter, the 2-inch nominal internal diameter, as you can see the paper removal interval is 2 inches, actually turns out to be 2 3/4 inches external diameter. This fits very nicely in the hand for a hand launch and is actually plenty large enough to hold up to about 6,000 milliamp hours worth of battery inside. This is good for light fun flyers. Any smaller diameter than the 2-inch is not recommended for two reasons. One is the torsional strength becomes very poor below this diameter, and two, the accessibility and capacity of the internal components is much decreased below the 2-inch. For this construction video, I'll be using the 2.5-inch nominal internal diameter fuselage tube for constructing the Ansley PD fuselage. But the principles I'll show you here apply to any fuselage diameter. The first step in planning your Ansley PD fuselage is to determine what wing chord you intend to use for both the canard and the main wing. Here I have some examples which are a 6-inch airfoil cord with no control surface, as this is the canard, and here's one that's 7.5 inches. That measurement is important regardless of the nominal chord. You need to actually measure that out. And for the main wing, of course, you'll have control surfaces on the outboard part of the wing, but not in the center. So be sure to measure the chord at the center, absent the elevons, to determine the actual airfoil chord. The chord measurement is critically important, as that will determine where your wing hold downs will be placed. Using the lengthwise method of a carbon fiber tube or arrow shaft placed through the fuselage like this, you can see they protrude forward from the front of the fuselage and are accessible here, that hold the rubber bands which are placed over the canard like this. Now this fuselage was actually designed for a 7-inch chord, which is why the overhang. Therefore this canard would not be optimally suited to this fuselage tube. I'm going to construct a new fuselage here with the dimension between the leading edge and the access point for the hatch to match this chord of the canard. If you prefer to use the transverse mounted wing hold downs like a carbon fiber rod or chopstick or dowel or some such rod, cut of course to a much shorter length than this, I recommend inserting them transversely through the fuselage at least an inch rear of the leading edge of the fuselage, and if you can imagine this turned around, at least an inch forward of the very trailing edge of the fuselage. This does have some implications with the motor mount in the rear and with FPV gear if you are using it in the nose. But locate that at least an inch from the end, and the second one should traverse the fuselage at the same distance as the chord apart like this. Of note, if you do decide to use the transverse or crossways wing tie downs, I highly recommend that number one, install it right up against the upper surface of the inside of the fuselage, and that will distribute the weight against not just the sides where the tie down protrudes through the foam board, but against this upper surface here. And additionally, I recommend installing something like a gift card or something stiff adjacent to the tie down, and then apply some glue along this to prevent any sideways motion like this, because with flight, use, assembly, and disassembly, I will guarantee you that hole will enlarge itself in a way that is irreparable once it gets really started. So work on affixing this to the inside of the upper fuselage, and that will lock down nice and tight and give you many flights. For this build, I'll be using the lengthwise carbon fiber arrow shafts as my wing tie downs, which additionally serve to relatively strengthen the entire length of the airplane fuselage. And so I will need to account for a 6-inch airfoil cord for both my canard and the main wing. So I'll simply measure 6 inches rearward of the leading edge here, and as you can see, that's where the leading edge of the hatch will need to be to allow access to the rubber bands which serve as the tie downs for the canard. And the exact same configuration is reversed for the main wing, where the rubber bands exit the fuselage at the hatch and loop over the same carbon fiber arrow shaft that passes from the very front back to the very rear. As for which side of your fuselage tube to make the top and bottom, I recommend using the doubled side, that is the part where you've placed the foam board joiner, using that as the bottom for additional reinforcement, as well as for more solid mounting of most of the components, which will be mounted, of course, to the lower surface of the inside of the fuselage rather than the upper. The upper part of the fuselage, if you're using transverse wing tie downs, should be reinforced with additional foam board and or gift cards or other stiff substance. However, for using the longitudinal wing tie down like the carbon fiber arrow shafts, you can see the force is borne along the entire length of the fuselage back to the very rear. Therefore, I do not find it usually necessary to reinforce the upper surface of the fuselage tube. Additionally, having a single thickness of foam board allows much easier placement of the hatches through the upper surface relative to trying to place a hatch through a doubled piece of foam board as in the bottom. Here I've measured back 6 inches from the nose of the fuselage and 6 inches from the rear of the fuselage, and that will be the edge of the hatch. Now, as to how wide to make the hatches, they need to be wide enough to allow you to get in and amongst your electronics and put your battery in and fit it and so forth, but not so wide that it unnecessarily weakens the side of the aircraft. You can imagine this is a natural weak spot, and this plane, which has taken a couple of rough landings, you can see it tends to crease right at the corners of the hatches. This is slightly forward of the corner of the hatch, and for that reason I recommend reinforcing the insides of the hatch, particularly at the corners, with a additional scrap of foam board like this one as it crosses the transition of the hatch. And so the width of the hatch should in no case be wider than to this point right here. So you can see the fuselage is allowed to radius up and over, and then one more thickness of fuselage over, and so that is just about 3/8 of an inch to this point, which is how wide I will make the hatches here. As for the length of the hatches, I personally like to take this distance between the front of the front hatch and the rear of the rear hatch, divide that in thirds, more or less, and allow the center part to remain intact for cross bracing internally for reinforcement, but still very generous hatches here and here to allow access to your electronics and battery compartment. Here you'll see that distance is 18 inches, and so I'm going to divide this center section of the fuselage into a 6-inch hatch, a 6-inch cross-braced center section, and another 6-inch forward hatch like this. Here I've made the markings for my forward and rear hatch, and I'll make the cuts through the foam board with a nice fresh utility knife blade, and I like to tape a ruler or straight edge right against where the line is to fall, but without obscuring the line. Press that down and make your cut just a little bit canted out. This is exaggerated, but about 10 degrees like this, just like the top of a jack-o'-lantern. It'll allow you to engage the hatch better without tearing up the edges. And I simply stab that in, drag it along till the end of the line here, and then repeat that for all the other parts of the hatches. Now that the 3 sides of the hatches are cut, it's time to pull up the hatch and make a hinge, but before doing so, go ahead and place your straight edge right across where you want your hinge to fall, and use a blunt object like an ink pen with the ball actually retracted, or the tip of some blunt scissors or anything like that, and just kind of lightly drag it across there. That's where you want your hinge to fall, and so that when you peel up your hatch, it'll make a nice fold line right there. And so now we have an access hatch. At this point we've got both of the hatches cut with nice hinge lines, and at this point the fuselage is perfectly symmetrical, the same at the nose and the tail, and so either end could transform into either end at this point. I recommend if you do have one end which is more square than the other, make that your nose of your fuselage, and if you have one that's a little wonky or a trapezoidal shaped, you can just make that the trailing edge, because as you'll see we're about to taper the trailing edge, and by doing so you can essentially make that deformity somewhat irrelevant. Now that your hatches are cut, it's a good idea to treat the edges both of the hatch itself and the opening. I like to use tape. I would recommend at least using some thin CA glue along the edges to avoid the paper from peeling up along the edges. But I like to use vinyl tape to cover the top of the hatch, wrap it around the edges, and then another couple of pieces around the sides just to protect the edges of the actual hatch opening. Packing tape works okay. It's very difficult to apply without wrinkles around these contours. Duct tape actually works pretty well, although it wrinkles in the sun. It's a bit on the heavy side. And this vinyl tape is intermediary in weight between the two. It's very smooth and slick. It's easy to apply, slightly flexible. It gives a nice finish on your hatches. Next, I like to recommend reinforcing the insides of the sides of the fuselage as well as the hatches. Now the sides of the fuselage, although these tubes are pretty strong, on a rough landing or a crash like this, the place where it tends to crease the foam board is at the corners here. So by doubling up the inside of the sides here and here with a piece of foam board, and I like to use a piece that's already been previously taped. Usually you can find a scrap, remove the paper from the inside here, and this will span both of the hatches from a couple of inches forward of this corner, a couple of inches back, and you could use a single piece here and a single piece here, but if you've got a long scrap, you might as well continue it all the way back to a few inches aft of the other hatch. And then the second reinforcement is of the hatches themselves. Invariably I find these doors, just from handling, will get a little wrinkle in them, which is pretty harmless, but it's annoying, and so I take a second piece of foam board just like this and glue it to the inside of the hatch like that. If anything, make it a tiny bit smaller than the lower surface of the hatch so that you'll be sure to be able to fit it through the opening of the hatch when it's closed. Options to apply this reinforcement include spray adhesive, and I can really only vouch for 3M Super 77. I've tried several other ones that melt the foam, and this one will even melt it a little bit, but a light dusting applied, held a few inches from the foam, not right directly on it, allowed to dry to get tacky for a few minutes, and can be applied inside. Hot glue or Gorilla Glue are also another option if you have a means of clamping the foam board reinforcement inside the tube, such as a piece of angle aluminum, for the half hour it takes for the Gorilla Glue to fully harden. If you're using the lengthwise carbon fiber or dowel wing tie-down method, where the carbon fiber rod or dowel rests up against the upper corners of the fuselage here, be sure you give yourself enough clearance from your reinforcement. You could bring it up right to here, although it's a little difficult to apply the rubber bands. I recommend giving clearance of about half of the diameter of the dowel or rod, or more. Of course, the larger you make your reinforcements, the more it'll weigh, but the stronger it will be. I'm going to place this right about here, and then glue that in place, spanning both of the hatches from here to here. Next, it's time to plan the motor mount for your Ansley piece drone, and if you've built one like this, which is perfectly symmetrical as far as the hatch arrangement and the distances, I recommend choosing the end of the fuselage tube which is more square and perfect, and using that as the nose, because your FPV gear and your canard will rest nice and squarely. And then choose the lesser nice end of the fuselage tube to apply your motor mount, and in doing so you're able to straighten out some of the asymmetry and imperfections that you have. There are a million good ways to mount a motor on the Ansley P-Drone. My preferred method is to use this L-shaped bent metal motor mount to which the motor is screwed through the rear. The advantage of this is it's very simple, relatively light. The disadvantage is that you're not able to access these screws for dismounting the motor after it is mounted to the airplane itself without removing the entire mount. So choose your preferred method of that. If you do go with the L-shaped metal motor mount, the options include mounting it up high like this, in which case I recommend a slight downward thrust angle as you see here. But my preferred method is actually to mount it down right about here, flush with the rear of the airplane for improved aerodynamics and improved strength of the rear fuselage by building up this area where you see the gap between the L-shaped motor mount and the upper surface of the fuselage, building that up with some foam and gift cards or a piece of balsa as you see right there. So I'm going to measure this drop down distance to the base of the metal motor mount below the upper surface of the fuselage here, and that's where I'll cut up a taper from the bottom of the aircraft. The point of tapering the rear fuselage up like this is threefold. The first is it provides better aerodynamic flow of the relative wind over the fuselage on its way to the pusher prop. This provides better efficiency and quieter operation. Number two is it gives you a space below the fuselage to mount the speed controller in such a way that it gets excellent airflow, but it's recessed above the landing surface if you land on the ground somewhat. This is optional, but it is a convenient place to put it. And the third reason is that by creating a discontinuity in the otherwise long, straight, parallel sides of this fuselage tube, which can flex like this into a rhomboid, is that you can create a stiff, reinforced area simply by adding this part of the fuselage which is not parallel to the lower surface. So this stiffens it up a bit. Some internal bracing will still be necessary, but this can help. In planning out the height of your taper, consider the height of your metal motor mount if that's what you're using, as well as the material you're using to build up that area. Here I've used balsa, but you can also use foam board interspersed with plastic gift cards. In considering the length of the taper here, it's best to make this distance far enough to accommodate your speed controller if you choose to mount it on the lower surface. And I recommend not going too far forward where it starts to meet up with the hatch, as this will create an ever increasingly weak area across here. So I've stopped short by about an inch, and in my case I've made this 5 inches from here to here. That'll make a nice taper, plenty strong, and good space to mount the speed controller beneath. In cutting this out, I recommend making the lower surface cut first so that it goes up the side of the fuselage about one thickness of the foam board here. That will create a little notch here so that when the lower fuselage lid, as it were, fits up in there with a nice smooth transition here without having to overlap. I like to do this by just taping a ruler or straight edge right across the desired cut area. Hold that down and use a nice brand new blade to cut right through that. And again, slightly up the sides. So you've come up the side about one foam board thickness. Then it's time to cut out these sidelines. Now I've cut off the taper part of the fuselage, and you'll see it's left this little notch recess which will accept the lower surface lid or hatch and provide a nice smooth transition there. You'll also note that the point being that if the rear of your fuselage is a little out of square and you need to adjust the main wing position relative to the canard, that is to get them in better alignment, you can do little tricks like by using the rear hatch. Tape it down or glue it slightly out of square. You can slide it to the right or left accordingly like this, and in doing so you can slightly change the shape of the fuselage before you put in that final bracing, and that will allow this surface where the main wing goes and this surface where the canard goes to be perfectly square and aligned like this fore and aft instead of like this or this. One of my favorite and more economical ways to build up this internal area to accept the motor mount here is to use layers of depapered foam board or Depron like this interspersed with plastic gift cards through which holes have been drilled I prefer to use Gorilla Glue, which when clamped together in between these cards and foam board will allow the Gorilla Glue to expand through these holes in and around all of the cracks and crevices of the motor mount, and then this, within the 30 minutes allotted, preferably within about 5 minutes, can be placed inside the fuselage like that, pushed flush, and clamped up in there with a final gift card right against the bottom where you can adhere your metal motor mount if that's what you choose to do. I'm going to use a piece of balsa here just because I have it. It weighs a little bit more, is a little stiffer than the foam board, and certainly not as economical. In either case, whether you use Gorilla Glue or hot glue or CA glue, I do recommend removing the paper from this part, the sides, the upper part of the fuselage, and the other side. And this will permit, whether you use the balsa or the foam, to engage the sides here and here when glued. That will provide some additional rigidity side to side for your rear fuselage. So if you use hot glue for this operation, I recommend just working fast. If you like to use CA glue, I recommend using thick or medium that's fairly slow setting to allow you to orient, organize, and clamp everything down. And if you use Gorilla Glue, which is the most secure and allows the most adjustment time, be sure to clamp this well vertically against something stiff, either against a work surface or table, or against a rigid member like that. And then what I'm going to do is use this piece of tape to close that gap there and there by taping this across. You can see the Gorilla Glue is beginning to expand out of the joints, and be sure that you don't get that on anything. It's pretty messy stuff. Now the motor block is glued in place either by Gorilla Glue, which is my preferred method, or CA glue or hot glue. It's in place. Now it's time to drill the holes either lengthwise to accept the wing tie-down rods that go the length of the fuselage, or the transverse ones. If you choose to use that type of wing tie-down, the holes will need to be made transversely through the block. Now you can pre-drill this, but I've found that CA glue, hot glue, and especially Gorilla Glue, as it expands like this, it will fill these holes, whether drilled traversely or lengthwise through this. So I typically prefer to either pre-drill them and then drill them out again after the glue, or just wait until the glue is all set and then drill afterwards. I like to use the lengthwise, and so I'll be using these carbon arrow shafts stuck into the fuselage all the way down the length of it, so it protrudes posteriorly like that, to accept a rubber band here. A rubber band having been pre-placed on the arrow shaft before I put it in, just as I just did, and then it will stick out the front to accept the rubber band here that will loop over, and then it will have been pre-placed over the arrow shaft here up in the corner at the hatch in the front, and then repeat that with the opposite side right here as you go. And the idea being that when you get to this point and the tip of the arrow shaft dowel or whatever is present right here, you slip the rubber bands over that tip, continue forward, and so the rubber bands will live right here ready to loop over the back, and then as it reaches the front, gets to right here, you would loop your additional rubber bands. I like to do 4 over the front there, and then continue pushing until it comes out the front, looping 1 rubber band here over the right side and 1 from here to here over the left side. Will hold these in place nicely, and the remaining rubber bands can be left in place to be looped over the canard in the front and the main wing in the rear. So essentially you get this reiterated 1, 2, 3, 4 times, and that is 1 rubber band that's looped over the shaft and exits the hatch right here, and that not only holds the shaft up into the corner intimately, but it provides a nice frictiony surface for the wing to sit against to inhibit any movement of the wing against the fuselage. And then here of course are the remaining rubber bands that would be looped over the main wing and the rod like that in succession, and then the hatch can generally be closed with a little bit of effort, just like that, and then repeat that all 4 corners. If you use this method, you can also safely release the rubber bands after flight, which I recommend doing to prevent them from stretching out and fatiguing, and then you can store them right inside the hatch if you like, even this one if you prefer. And if you break one of these at the field, this one can always be your spare. The next step will be to actually install the motor itself, and I've used the angled motor mount here with the Scotch exterior heavy-duty mounting tape, and I'll stick that right to this gift card, which itself has been Gorilla Glued to this block of balsa. This type of joint is incredibly strong. I can tell you it's almost an extreme effort to get this off of a crashed plane, but even if you have any doubts, note that the force from the thrust of the motor is actually not borne by the tape, but by the face of your motor mount here. So if this is aligned correctly, as it is parallel or with a very slight down thrust, not more than about 3 degrees, you'll see the motor pushes right against the face of that block. And in this case, my metal motor mount fits nicely right between those wing tie-down rods. And so this is accomplished by just removing the backing from the tape here, getting it lined up like this. And I like to actually push it a little far forward, engage the tape, and then press it down as I go so that there's a bit of tension between this piece of the metal motor mount and the face of the motor block. You can also consider, if you overdo the thrust angle, you can gently bend this out and put pieces of gift card or other shim in between them for example, if you have too much of a down thrust angle like this, you can reduce that by shimming it. After applying the motor, we'll build the hatch for the rear fuselage taper with or without the ESC contained in it. I will remove the motor just for demonstration purposes, not having mounted it. And so all I've done is cut out a piece of foam board as a scrap. This happens to be also taped on the inside. It's perhaps a little bit stronger. Notice it fits nicely in that notch. Comes right to the rear, and there's a very slight gap for ventilation as well as for the wires of the motor to enter the fuselage and then join up with the speed controller, which I'll put right here. So I'm using the Turnigy Trust, a 55 amp speed controller here, which has these very generous heat fins, which not only provide excellent cooling, but you'll see that it causes the heat sink to stand up and away from the printed circuit board and the guts of the speed controller, and it provides a nice little sort of cookie cutter template here. And I'd like to locate that right in the center of my fuselage taper hatch. So I'm just going to put that on a firm surface, use the heat sink, center it like that, and give it a little push down, and you'll see that it makes a little impression in the hatch. I'll proceed to cut this out a little bit larger than the outline that you see here, and beveled a little on the inside to make up for these slightly ramped up tapered areas here, and that will allow the speed controller to fit right up in the foam board and become flush with the outer surface of the hatch. Here you can see the speed controller is mounted on the rear fuselage hatch. It's nice and flush there and centered. There's the speed controller inside, and I'll just tape that around a couple of times to both affix the speed controller to the hatch as well as to sort of dress up these corners here. And for closing the hatch, if you ever expect you need to go back in to do maintenance, and you always do, I recommend first taping the edge of the fuselage here, here, and here, and then applying the mounting tape over that. That permits you to remove that tape without risking damaging the edges of your actual fuselage in case you need to open this up to service it and then reclose it. Now the fuselage taper hatch is all taped up, including the edges there, and it's ready to be taped down with the ESC in place, wired up to the motor. Also, fun fact is a pusher motor, as long as you're absolutely certain that the rotation is correct, you can actually omit the C-clamp there, or the E-clamp, and it can just pop on to fly, and it will always push against the bearing and not pull. But I'm going to remove that just for clarity here. Before taping this down finally, remember you can make some fine adjustments for the alignment of the fuselage by the way that that's taped down, by wiggling it a little bit. So first, install the bulkheads, and I recommend putting one here and then one in front of the hatch here. And what these will do is to avoid some of the small degree of torsion, that's the twisting of the fuselage that can occur, that would misalign the main wing from the canard in flight. The larger the diameter of the fuselage, the less prone they tend to be of this, but I still recommend cross-bracing or putting some bulkheads at least a few positions along the fuselage to avoid any excessive twisting. Making these stiffening members is a matter of accurate measurement and trial and error, and what I'm going to do in this case is design one to fit right against the doublers on the sides of the fuselage here and here that will slide right back in there, and that would be this one. So I've measured the diameter inside and design this piece of foam board. And this is a case where I actually like to use the really heavy, stiff foam board with the heavy paper facing, just for strength. I've cut the corners off to permit the wing tie downs to have a space there, and then a central place to allow wiring for FPV gear, which will go in the nose here, to fit. And so there it is, resting squarely on the inside of the nose. And do be very diligent about making these square, because while they will stiffen your fuselage, if you make these crooked, they will also twist your fuselage and make it out of alignment. And so be very careful that your corners are square, that the sides are parallel, the top and bottom are parallel, so you make a nice square or rectangle. Whatever the shape of your fuselage, you want to maintain that shape and not distort it. The second one is going to be a little different because the doublers are present here and here, so the width is narrower. So I've cut this one to fit that space. Also the place for FPV and other wiring to go through. In fact, the power supply to the ESC will pass through this bulkhead. I'll just put it in place and slide it right up against there. Get it nice and tight. Make sure your sides are nice and true and straight. You can sort of use your eyeball and look down this way. You can use any number of longer straight edges along the side or a flat surface, but your eyeball is probably your best tool. Pretty strong. Now the next step to ensure the alignment of your canard and main wing will be to either install the canard and main wing, or you can use a proxy like a couple of chopsticks or carbon fiber shaft or arrow shaft, and put them sort of where the main wing and the canard would be, like this, so that these are now parallel to the front surface mounting for the canard and the rear surface mounting for the main wing. And then, I'm not able to demonstrate this on camera, but using your eyes, sight down past this rod in comparison to that one. This one, sight down it in comparison to that one. So these should line up and be perfectly parallel. If one is facing this way and one is facing this way, that's exaggerated. You'll need to take measures to straighten that, and one way of doing that is to use the final taping down of this rear part to put that tiny little twist in it, this way or that as you need. So like this, or a little bit like that, in order to make this surface perfectly parallel to this one. So here's the Ansley PD fuselage all finished. There's the nose with the stiffening bulkhead in place. The wing tie downs, either the lengthwise or transverse. Rubber bands are installed, stored in the forward hatch. This is where the battery compartment will be. We'll come back to that in a future video. The hatch is created and covered forward and aft. There's a stiffening bulkhead there. Rubber bands in place. Speed control power supply is accessible for future wiring here. Here are the wing tie downs for the main wing. The motor mount is installed. The fuselage taper hatch is in place. The ESC is affixed. And the motor is in place. Rotor is installed and ready to wire up.